So let's talk about formulas that we learn in school. I'm sure everybody remembers the infamous area for a triangle. Let's try to forget that for a second. I'm going to show you the way that Paul Lockhart talks about this. There's a book, well, it was originally an essay that he wrote that it went around called The Mathematician's Lament. And he talks about one of the first problems he shows is how to find the area of a triangle, but from an intuitive way instead of using a formula. So I'm going to show it his way, but then I'm going to show you my way, which I think might be even more intuitive, but you can decide. So the way he shows it is that there's a lot more. It's a little more complicated than I would do it, but um, so initially he shows a triangle, and he says, let's draw a box around the triangle. So I'm just doing this quickly. I'm not trying to make anything perfect, so bear with it. So he asked the question, how big is that triangle? And I guess how big is it compared to this rectangle here? So you might ask the question, he asked the question, I don't know, maybe it's 2/3 or 3/5 of it. Who knows? I'm not sure. So what he shows is that you can draw a line that's perpendicular to the bottom line and touches the top corner like this. So it's going from here straight down, and then that little square at the bottom means that it's a right angle. Also, this angle then equals that angle. So he says then, okay, now you can see that this triangle is the same as this triangle here, and this triangle is the same as this triangle. So that means the triangle itself, the whole triangle, takes up 1/2 of the rectangle. And we know from early on geometry that the area of this rectangle here is its base length times its height. And since this triangle we're interested in is 1/2, then it's 1/2 base times height. Now, I think this is great because, having to memorize 1/2 base times height is kind of lame, and it doesn't really give you that much, I don't know, insight. It doesn't give you insight, it doesn't give you intuition or anything like that. But when you look at it like this, it's actually a lot easier to just see it and wrap your head around it and even derive it if you need to. But I'm going to show what I think is maybe even a more intuitive way. And I think this is this is kind of shocking, in one hand, but this might be even more so because almost all the time, you'll find things in mathematics which are just kind of so shocking. It's almost scary. I mean, it's not scary in a bad way, but it's just like, what is going on here? Like, why does the world behave this way? Why is mathematics like this? Why is the world created in this way? Could it be any other way? It seems like when you start studying numbers and shapes, you almost start seeing the matrix, basically. Like there's some kind of code behind it. So here's what I would do. I would say, take any piece of paper, any kind of rectangular piece of paper, it could be square or anything like that. It doesn't matter what shape it is. I'm just going to pick a point somewhere along one of the edges. Okay, let's say it's right here. And then I'm going to connect the corner to that point. I'm going to connect the opposite corners to that point. And maybe you don't know how to draw this height. You know, it takes, you have to draw a right angle from the bottom. You have to know exactly where it intersects. It's a little, I don't know, it's a little more complicated than it needs to be in my opinion. But you could just take a scissors and you can cut out along that line, along the line that you drew. And then we'll also cut the other one out. And there's my triangle. And I'm going to take the two pieces I cut out and I'm going to lay them over the top here. Oops, did I do it wrong? There we go. It's exact. That's crazy. To me, it's crazy. And this doesn't matter what shape piece of paper you have. It doesn't matter how you draw the triangle. It's always going to be half. How does a triangle know how to do that? How does a rectangle know that that's what to do? It's so strange. So you could draw, you know, you could draw one like this, kind of like what we already did. We could, let's use a different color, use green. We can make one here. Let's make a red one. So all of these triangles we just drew, they all just take up half of the rectangle. Pretty interesting. And that doesn't matter, you know, you can have very, you know, you can fold your paper in half the long way and still the same thing every time. That still only takes up half. Crazy. At least I think it is. It goes deeper. If you don't think that's crazy, just wait. So I'm just going to bring up one other thing about, if you're messing around with this, and you might say to yourself, okay, great. So we draw a rectangle that has this triangle inside of it that's touching these corners. Cool. But maybe not all triangles look like that. So maybe you have a triangle that looks like this. It's very obtuse. It has this very big angle here. So how does that work? I mean, if you draw the rectangle around it, is that still going to work? Or do we just break math? Does not look like that is equal to these two pieces, for sure. So, is there a way you can fix this? Or you can see a way around this? Or did I screw something up? Or is there a rule that we should be applying here? I'll let you go have a think about that and see what you come up with. And I'm not even going to tell you the answer. Figure it out yourself. All right. I lied. I'm going to tell you the answer. Okay. This is my best attempt to copy this triangle here that did not work. Now, what we could do is, you don't have to draw the rectangle from the bottom. I mean, it looks like we kind of added something on there, whereas you know, when we did this one, the bottom of the rectangle, I'm talking about the top picture here, the bottom of the rectangle is exactly the same as one of the sides of the triangle. Here it's not. We added this little bit on there. So that's probably the problem, right? I mean, so what can we do? Well, if we drew it straight up, that still wouldn't work. So maybe a good rule is that we always use this long section of the triangle as our base of our rectangle. So we would draw it like this. So maybe that's a better way to approach it. But I don't know. Maybe you can figure out something else. I think it's a fascinating problem, however you look at it, and just a very interesting result. All right, until next time.